So new tools are sort of making their way into delivering on this sort of promise of bringing structural engineering functionality actually inside of Revit and not leaving it outside where it's totally disjointed or that sort of thing. So we're going to learn about some new tools and technologies to bring the world of thank you so much, bring the world of structural engineering into Revit, whereas we've always been sort of segregated out to our analysis software and relegated to links and that kind of thing. So there are new inroads that are being made, harnessing a lot of technologies that are available. We're going to discuss those, some of those technologies, Autodesk 360, structural analysis in the cloud, which is interesting for a couple of different reasons, sort of showing direction as well as increasing capabilities. We're going to look at the analytical modeling. How many people in the room, let me just sort of get a sense of the room a little bit. How many people in their firm are using Revit? Let me first do, how many people are structural engineers? Okay, keep your hands up for a second. How many people that have their hands up right now are using Revit on a day-to-day basis? Okay. How many of those people are using the analytical model functionality in Revit on a day-to-day basis? Okay. Of those same people, how many people are really familiar with the analytical model, totally understand it? Okay, good. I don't want to bore you guys with, I mean, I've talked about the analytical model in Revit for years now, and I feel like it's an old topic, so I didn't want to, sort of drown you guys with some boring stuff. But this sounds like it's going to be a little bit exciting. It'll give us a chance to do a little bit more of a demo. I'm glad to see there's so many structural engineers in the room, because that's where I came from. So our objectives today: describe the key technologies that enable integrated, I'm going to stop tripping over the chair here. You'd remember this presentation. Describe the key technologies that enable structural engineering workflows in Revit. Understand how Autodesk 360 structural analysis fits into that sort of workflow. And then how to utilize the results explorer in Revit to really, I think, I stopped last night and stepped back from my computer as I was still madly trying to practice my demos, and went, Revit really looks like a structural analysis package when you look at it in a certain way, and I hope that you see a little bit of that when we get into the demo, and be able to describe one or more examples of integrated design applications built on Revit. Since I told some other people earlier, just as they came in, that I just found out a couple of days ago that this class is a 90-minute class and not a 60-minute class. So everyone said talk very slowly. Instead of doing that, I'm just going to add an additional objective and kind of try to talk a little bit about where we are as an industry and how our industry is evolving and how I see it, and how I hope to encourage you to think a little bit differently about, I wonder if I put mine on vibrate. That'd be embarrassing. Think differently about using building information modeling in your workflows. So the format, dynamic talk, maybe less dynamic demo. And then we might play 20, 30 minutes of Stump the Chump if you want. A little bit about myself. I'm a structural engineer by training and trade and practice and everything else. I spent about 7 years up in the great state of Maine, Bold Coast, doing structural engineering. We did steel joists, kind of simple, basic engineering. My specialty was middle schools. That's all we did. I don't know why. So what things got me interested in building information modeling? Does anyone know Tom Tyson? Anyone been involved with the ASCE 7 committees? Anything like that? No. Tom was an engineer. I met him when I worked at the Sear Brown Group in Rochester, New York. That's where I grew up, born and raised. And Tom, back in 1991, had done his PhD research in effective automation for structural engineering. And he basically painted this picture of what the future might look like in terms of, in terms of a fully integrated workflow where we have one centralized database, a la Revit, and links to various functionality. So he sort of envisioned it like there's a central database, and that database was the repository for all the information. From there, we do our structural engineering, we do our analysis, we do our documentation, and we might have some special design modules. And surprisingly enough, I think that sort of planted a little seed in my head way back when nobody was, at that time, Sierra Brown was like, we just got one AutoCAD station and we're trying it out in the tower. Everyone's on Intergraph stations doing massive, these multi-monitor Intergraph stations. Did anyone work in an office where you had a fishbowl? Where that you walked in, Sierra Brown had a fishbowl. You walked into the front office and there was this glass-in place where they forced various drafters to work. So that clients coming in could sort of get impressed by the massive CAD stations. It was an interesting place to work in time. And so in practice, doing structural engineering, we've all been through it. Working a CAD workflow where you've got a different drawing file that represents every single sheet in your sort of drawing set. Coordination is a nightmare. How many yellow pencils have you gone through? Think back. You probably own the yellow pencil company by now, right? So everyone uses yellow pencils, right? That's what we do? Yeah, or red, if you've got to mark up what your drafter didn't get right the first time around. I call it the drafting half-life. Send it off, you get about half the things right, none back coming. So, obviously, I started to look at things like, I was telling someone earlier that I put together an elevation view, put the sizes on there, put a plan together, put the sizes on the plan, went through the process. Contractor, after they win the bid, calls me up and says, so Ken, what size did you want? Did you want the W12 or the W18? And I was like, he's like, because I bought the W12. Great, so now I gotta tell him it's the W18, and he's gotta buy a new one, and I gotta get a change order, and so the owner's like, do you know what you're doing? My boss is like, do you know what you're doing? It's embarrassing, and nobody likes that. So I started to think about how can we utilize technology in different ways that we're not currently using it to drive coordination, to make things more consistent. And so that's where I sort of got started. And I have this sort of strong desire to harness technology for these kinds of things. And it drives me to investigate various solutions that may be unusual or obtuse at the time. I started coding, good morning, Joe. So you snuck in over there. Started coding at the time what? Good. How many Joes in the room? Oh, just the two. Just the two jokesters. All right. So I started coding at the time what I envisioned to be very much like Revit on AutoCAD as a platform, using the Object ARX code set at that point. Got about a year into that project, and I discovered Revit. And even at Revit Structure 2.0, I was like, what am I doing? Like, why am I wasting my time with this? So I, again, this is where I get propensity for developing my own solutions to problems. Does anyone not use an Excel spreadsheet to do design? Right. We all do it. So we're all in that sort of like developing solutions to our problems because we want to use custom, we want to do something that we're familiar with, we want to understand what's going on in our calculations. We don't want to use black boxes necessarily. So that was the pre-Revit structure. I don't know. I didn't even have a name for it. It was that early in the inception. But then when I saw Revit and I couldn't get my company interested in buying it at the time, it was a new thing. It was 2004. It was scary and it was expensive. It's still expensive. But I saw a job offer with Autodesk and I jumped at the opportunity to go join them. So I worked with the QA staff at Revit, with the Revit structure for about 7 years. Morning, Thomas. How you doing? Sorry, making a late entrance. Wait, are you going to come sit in front and heckle me?
Yeah.
Oh, man. All right, so worked with Autodesk for 7 years in the QA department and wanted to help them bring my knowledge as a structural engineer and sort of my vision as where this thing could go and help drive designs and QA. And so I got to participate in some of the design discussions and that sort of thing. I was involved in designing one of the features that we're going to see today. I'm kind of proud of it myself, even though it could be better, but why do everything perfectly the first time? So since I have some extra time, I'm going to wax a little philosophical and continue sharing some of what I see as where we are, vision, the state of what we're doing, and want to try to encourage you to think about the future in terms of how it could look as opposed to where it is now. There's a lot of possibilities and a lot of interesting possibilities that are getting more and more interesting every day. Anyone seen or attended a presentation on Dynamo BIM? Few people. Interesting? Very interesting. It's incredible what you can do with this stuff now. And so we're sort of bringing this type of stuff and making it really available and really accessible to people. So I want to talk about the destabilizing event of our time. I miss Boston. I'm from Boston. Came here. It's probably snowing there right now. I don't want to talk about this car, though. I want to talk about this car. This car changed the world. And I don't mean this one in particular, but this era. Forced people to reconsider how streets were used. So before, I mean, this is a scene of a street, right? Think about that for a minute. People selling food, children playing in the streets, things that we would think of as ridiculous in this day and age. You know, so uses of the street before, walking obviously, gatherings, demonstrations, and celebrations, buying and selling food, children playing. The automobile was met with a lot of resistance, a surprising amount of resistance. People hated it. They hated how it was affecting their lives because of the way that they were using streets since eternity, because we didn't have cars before. So there were safety concerns, displaced users walking and playing, concerned businesses. How are customers going to access my business if there's cars in the street now and they can't walk to my business? And cars were literally regarded as violent intruders in this common space. Think about that, how much we accept cars these days and how much they've affected our lives. So how did that, what did that cause? It caused an evolution. The evolution was it led to new and evolving roles. We didn't have traffic officers before because we didn't need them. But now we have to deal with this. Now we need traffic engineers. We never needed a traffic engineer before. So now we're creating new roles and positions and responsibilities, and we're learning new things. And it led to new regulations. Jaywalking was a huge problem at the beginning because cars moved a lot faster than people were used to anything moving. So we needed jaywalking laws to keep people from getting hit by cars. And people were getting hit by cars a lot. If you read, there's a book, I'll try to figure out what the title was, and you can ask me later. But it's a book about sort of the impact of the automobile in America and the world, perhaps, and how much danger it was, actually. So traffic laws, speeding's defined now, violations, moving violations, things that we didn't think about before, didn't have to think about before. It led to the extinction of some things. Streetcars were no longer a thing. I mean, some of them hung on for years and years, but they mostly left. Pedestrian street use. Not just sidewalks, but literally people walking in the street, and play in the streets. So unhappy children, no playing in the streets anymore. Now if you tell a kid to go play in the streets, you get in big trouble. So what were the benefits of this change? I mean, you could probably think of more. I thought of a few after I put the presentation together even. Vastly increased freedom of movement. We could go almost anywhere that we wanted to if we had the time, and really fast, comparatively speaking. It expanded our reach, allowed development of the suburbs, allowed us to think about and access travel differently. But it also irrevocably changed the way we use the streets. It just did. We couldn't use the streets in the way that we used to make way for this progress. So what is our modern day destabilizing event? BIM. It's come. We can't deal with it like we could AutoCAD, right? AutoCAD was no problem. We had a drafting staff. They worked on drafting boards. We swapped out their drafting boards for computers, and they figured it out, and we worked the same way. Engineers engineered, drafters drafted. That's how it worked. And it's how it's worked for a long time. And I'll bet that a lot of people in the room are probably still working with a very similar workflow, even if you have Revit. It's forcing us to reconsider our workflows. It's not just a tool for drafting and preparing construction documentation. It's a real tool that how many people in the room are to have a conference room set up now with a big screen monitor and a computer? Of those same people, how many people had that 5 years ago? Does that tell you something? It's changing the way that we do our business. And it's giving us a lot of benefits. Engineers engineer and drafters draft, highest and best use of our time, etc. But I'll bet you money, maybe, I don't have a lot, that I could outdo the engineer drafter workflow by myself with Revit. So I talk to a lot of people who are like, we don't really use Revit unless the architect requests it, we don't really like it. And I hope that I can encourage, if anyone's in that position, I hope I can encourage you to see how these things the technology has evolved so much that it really offers us new workflows and new opportunities for doing our work. It's being met with resistance, right? It's too expensive, don't have enough fee for it, etc. You've heard all of these. You may have used some of them yourself. And we still have this IP problem where how do we, as structural engineers, architects have to stamp drawings, but they just kind of put it in their title block. Whereas I think when we're structural engineers, we really feel like we're taking responsibility for this thing. And I don't think anyone in this room, including myself, probably would ever use a stamp lightly. And so it's an important thing, and we consider it important. And having control over the state of the documentation and making sure that it is what you designed is important. It's forcing us to consider and create new workflows and roles. Did we ever have a director of virtual construction before, or virtual documentation or design, whatever it is? 15 different permutations of that name. That's a totally new thing. BIM managers. Our new BIM manager in the back of the room. We never had one of those before. And now we're starting to have these new roles evolve. So I hope you can see how it's surprisingly parallel to this massive disruptive change in our lives, the automobile, and it has a lot of correlations. New regulations are evolving, levels of detail, divisions of work, or whatever it is. What do we call them? Divisions of modeling responsibilities. Who's going to be responsible for modeling the walls? Who's going to be responsible for modeling the foundations? People been involved in discussions like that? Absolutely. All the time. And so these are the kinds of things we're dealing with. It's also offering us unprecedented opportunities to change the way we work and to harness these new technologies to increase efficiencies, et cetera. So what do we got? Widespread adoption by engineering drafters. Most of our drafting staffs have probably at least investigated BIM, if not are using it on a day-to-day basis. Obvious enhancement to coordination, increases speed and efficiency, blah, blah, blah. Limited adoption by engineers. So I think we had 0 engineers that are using it on a day-to-day basis, right? Yeah. That's not a big surprise. Every company, you'll find, if you've had a chance to talk to some other structural engineers, you can talk amongst yourselves later, you'll find that you're somewhere on this scale of no adoption at all to some adoption to full adoption. There are companies, anyone from Thornton Tomasetti here in the audience? Thornton Tomasetti literally has okay. They have a development department that does computer coding, like they're writing computer code. They literally do. So imagine how deeply implemented they are with Revit and BIM and sort of this whole technology, if they've invested that much in having developers on staff. But by the same token, for engineers, there's a lack of solid integration. How do we use Revit and our structural analysis tools together? We need integration for those things. I did do that, didn't I? It's kind of the same point. Lack of integrated tools. We use a lot of tools, we use a lot of technology like Excel to drive our designs, and there's not a whole lot of integration between those things so that you could actually conceivably work inside of Revit and do your design at the same time. We're always going out to Excel, we're going out to whatever it happens to be. Reza, Robots, Rad, Stam, STAD, RAM, whatever those things are. And there are all different levels of integration. And you've probably struggled with integration of this software has its own quirks. Integration of that software has its own quirks. Even the one that I say boasts the best integration, which is robot structural analysis, has some quirks. I don't work for Autodesk anymore, I can say that now, because it's true. It's just the way that it is. There's also there has been traditionally lack of focus on engineering workflows. So what can we do inside of the software? If I can only model, Well, that's only half of my job. I've got to produce a set of documentation, but all that involves calculations and analysis and design and all of those things. So how do I facilitate that workflow inside the product? And I hope that today you get a bit of a glimpse of how that's possible, or how it could be possible in the future as some of these tools. So we in this room, I think, are all guilty, structural engineers in general, of being too busy. Anyone not too busy like to talk to you afterwards? Increasingly tight deadlines. This is pretty obvious. Has anyone looked at ASCE 710 versus ASCE 798 or 05? That's insane. It's almost 2 times as thick. So these codes are getting more and more verbose and more geared towards software and the application of software to sort of digest those codes and apply the combinations and the calculations. And we're also guilty of being good at what we do. Why change a good thing? What we've got is working. I do the engineering and I hand it over the wall to my drafter, and then we do this red line half-life cycle, and eventually we get it out the door, and then we have RFIs, and no big deal. We always have RFIs and addendums. I had one project that I was up to addendum sketch number 54, and I thought I was going to go insane. We can change that. I talked to a firm down in New Zealand, and they told me after they with their implementation style of Revit structure, they had a project go out with 0 RFIs. Think about that for a minute. 0. It's almost unheard of. You can't even imagine it, probably. It's a little tough for me to believe. He said it was only 1. They had some other ones, but they were really low. It was 1 or 2 on other projects. I think most importantly, we're sort of hesitant to get involved in making this change. There's a lot of ways that we can access and drive and influence the technology that's developed. I think in a lot of ways I don't want to speak for everyone, but we can kind of be victims of the software development. What are the software developers doing, and how it affects us is really important, and we don't necessarily always get a lot of say in that. But I would like to encourage you to think about that differently in terms of you can get involved, you can reach out and contact these people, and especially Autodesk. When I was a structural engineer, I thought of Autodesk and AutoCAD, we use AutoCAD of course, as being this unreachable, untouchable company. But they're really not. I mean, they put this AU together, they invite you all out here. How many people have met one or more Autodesk employee while they've been here and chatted with them? That's access. I mean, you're getting a chance to talk to the people that actually influence the software in some way, shape, form, or another. Whether it's a QA person like Joe or I used to be, we talk with the product managers all the time. Hopefully you've had a chance to talk to the product managers, or the designers for robot structural analysis are literally downstairs. You can go talk to them, see what the next version of robot structural analysis, whether you use it or not. Might be interesting to see what they're doing with it. They're down there. So I would encourage you to sort of reach out and get involved in some way. I think we have a lot to gain. Anyone in the room tell me what the 3 C's are that's not an Autodesk or ex-Autodesk employee? That's not fair. Anyone know what the 3 C's are? We're looking for a software that helps us stay coordinated, consistent, and computable. And so in the original Revit architecture, what we thought of as computable as room areas and volumes and that sort of thing. Now as structural engineering starts to come in, we're thinking about computable in terms of, can this model be analyzed? Can we utilize the data in there to extract out an analytical model that we can then run through our analysis packages and analyze? So having a consistent and coordinated model should be fairly obvious in terms of its benefits. You avoid those things like, I've got an elevation that doesn't agree with my plan, which was embarrassing. So we can reduce errors and omissions, increase our efficiency. I hope that most people, anyone implemented BIM that doesn't feel like it's increased their efficiency somewhat? Yeah, if you do, if there's anyone like that, talk to me later. Increased confidence. With a disjointed workflow, where I do my analysis and design in some other software, how can I be confident that what's going into the model or what goes onto the final documentation is what I analyzed and designed? That's a huge issue for us. So having these things work at a distance from each other, even though they might be on the same computer or in the same office in the next cubicle over, it's still a disjointed workflow. So some of the things that we're going to look at today, I think, hopefully will give you a little bit of inspiration in terms of gaining increased confidence by using these technologies, increasing our profit margin. At the end of the day, it's all business, right? We want to make money. This is totally up to you, of course. With all of these tools and technologies, you could just do more work in the same amount of time. You could investigate more permutations of the framing system. Do we want to use deck at 6 feet on center, joist at 6 feet on center, or do we want to use composite, or do we want to use whatever you want to do? You can run through more permutations of your design because you have access to these tools. That presentation that I suggested everyone check out, Rob May from Tuesday morning, he was able to use this sort of visual programming language to drive robot structural analysis, not just drive it geometrically, but automate the analysis, take the design and analyze the information, and bring it back and feed it back in so we can optimize a structure based on sort of round-tripping those design results. It's insane. I hope you'll check that out. I was really impressed with that. It blew me away. So I want to encourage you to think that we can take charge of and drive technology as engineers. We know how to program, most of us. We do it at some level in Excel every day. We know what we need to do as well, and getting involved. So like I said, we've already been doing this. We do it with Excel all the time. Maybe some people have written sort of C# code or something like that, or maybe people have started to dabble in the API or the Dynamo. Some of the most useful tools, I won't mention them by name, but some of the most useful tools developed, I think, and used by structural engineers were originally developed by structural engineers that wrote the code. And then as they started to become a bigger company and they started to get a lot of developers on staff, it changed. And you could see that change in the way that the software worked. If you want to know what that was, you can ask me later. Democratization. Anyone tell me what democratization means? Bueller? Joe! You're cheating. You're an Autodesk employee. Yeah, making software accessible to everyone. And I think that Autodesk is doing an incredible job with that. If you haven't seen anything on Dynamo BIM, being able to bring the power of API programming to someone that doesn't necessarily want to write C# code in Visual Studio is a really powerful democratization. We're going to see some more things about that as well. And Autodesk is a very strong supporter of what they call a development ecosystem. They've realized a while ago that they can't effectively develop and support engineering at every corner of the world. So there's 100 and something countries around the world, 70 or 80 different design codes around the world, and that's just the major ones. How does one company support all that? You'd have to have, and then to do it at a distance. So you have someone in, let's say they're in the US and they're writing the code for China. Imagine how challenging that might be. So Autodesk is strongly encouraging and supporting this development ecosystem of third-party developers that are experts in their field, have been doing this sort of thing for a long time, and understand the local codes to give and to drive sort of design and code checks inside of Revit. And later we're going to look at one example from a company called Sophistique, and then we're also going to look at an example of building on this code checking framework. Has anyone read through the handout? Glanced through it? It was kind of long. I just got rolling and it just happened, so sorry for that. But we'll take a look at an example of using the code checking framework that's been developed and published by Autodesk for us to do things like this. So yeah, I'm ahead of myself. I think Autodesk is really leading the charge in terms of this democratization, bringing these tools and technologies to us, opening them up, and making them available for us to utilize, for developers to support and supply localized code checks, and to really bring engineering inside of Revit. It's a whole new world. It's driving these capabilities for workflow. Analytical idealization, what do we need? We need to be able to idealize the structure. We're not going to do a volumetric finite element analysis of our structure, most likely. So we need to be able to idealize that structure analytically. We need to be able to perform structural analysis in some way. We need to understand those results and digest them, get comfortable with them, make sure that the model's performing the way that we want, and enable engineering workflows, code checking, and design. So the key technologies we're going to cover, I want to talk to you about the things that Autodesk has done over the past, I don't want to say 8 years or so, to really make these things a reality, or to build out at least the platform upon which third-party development can take charge and deliver these technologies to you, deliver advanced technologies. And I'd like to also kind of encourage you to think about this in terms of yourself. There's nothing stopping you from writing your own code checks for Revit, using the API, or especially now with the Dynamo BIM. Digging information out of Revit is easier, English is gone, than it has ever been before. And so it's worth thinking about and talking about. So these key technologies, the analytical model in Revit. How many people have at least played with the analytical model? Okay, it's pretty good. So you got a little bit of a sense of it. So you guys, if you want to take a nap, you can take a nap at the beginning of the demo, because we're just going to go through the analytical model. I think there's enough people that haven't really looked at it or seen it or understand what its capabilities are, and I want to talk a little bit about that. Autodesk 360 Structural Analysis is taking the robot structural analysis engine, extracting it as a sort of a headless thing, putting it in the cloud, and letting it service structural analysis directly from your Revit environment. So you're not going out to a robot, you're not going out to a different structural analysis software. You're launching that analysis directly from the Revit environment. So it's using the analytical model that you define in Revit, and it's driving that analysis and bringing those results back for you. You can also link, of course, with any of the other softwares that provide links, including robot structural analysis. Results package support was a huge change, which nobody really knows about. Results packages are, it's technology that allows the storage of massive amounts of result data, any kind of results, in Revit. So structural analysis results, wind simulation results, required reinforcing. That's what we're talking about. Sorry. I only got about 4 hours of sleep last night. It's been a rough adjustment to Las Vegas. So this results package support allows us to store. So in the same, like sort of the concept that Tom had years ago about integrated structural engineering, having a central repository of results and data that we can work with, now Autodesk has supplied third-party developers in the API with the ability to store these results back into Revit for you to utilize and to investigate and to digest and that sort of thing. So it's really under the hood. I shouldn't say that. You do interact with it, but you may not realize how important that is. And it doesn't impact the model performance either, because it's separate and it's stuck on the side. It's in there, but it's not sort of increasing your model demand or performance demand. The Revit API almost goes without saying. It is such a powerful development tool. So much of the Revit database is accessible to API. So much of it can be manipulated and managed and data mined out of it and changes pushed back into it. And I do Revit API development, and I stand impressed on a day-to-day basis about how much that I can actually do with the Revit API. So it's really impressive what Autodesk has done. Internally, everything's developed with an API. So all of the tools and commands, they don't always expose it all to us to use, but everything they do is they always think about, when they're developing something, they're always thinking about, how do I expose this as an API for people to use? So I hope that makes some impact. The analysis visualization framework, this is one of the things that I was involved with designing a portion of. This is a framework that's also API focused, that allows people to take those results that are stored in Revit, or results that are from anywhere else actually, and generate graphics in the Revit views for you to look at and view. We're going to see a demo of that later. We'll take a look at how that works. And there's a lot of control that you can have over that, so you can really start to use Revit in terms of preparing your documentation for your calculation reports. It is possible. And the last piece of key technology is the Revit code checking framework. Has anyone seen or heard about the Revit code checking framework besides Ben in the back? Anyone else? A couple of people? Thomas. The Revit code checking framework is a set of technologies and software development kit that Autodesk spent quite a bit of time developing in order to facilitate third-party development of code checking and design applications. So it creates a bit of a consistent user interface. We'll look at those commands and controls and an example of how you could develop a code checking app on top of them. But these are the key technologies that Autodesk has implemented over the years to really facilitate these types of bringing engineering workflows inside of Revit. We're going to focus on the analytical model, 360 structural analysis results, but we're not going to talk about the Revit API because everything sort of is founded on that under the hood. We're going to look at the analysis visualization framework and the code checking framework. So, any questions, comments, concerns at this point? Everyone still feel like they're in the right room? That's a good sign. No questions at this point? Okay. Now we're going to they asked me to put up little slides before the demo, so I'm going to take a little load off here and do some driving. So I've just got a simple model. I don't want to confuse this issue too much. You can get as complicated as you want, of course. The first thing we're going to do is talk about the analytical model. Computer's been a little bit fluky this morning. As soon as I plugged the video cord in, it crashed. So I'm a little bit nervous right now. That's much better. So that's, we're in Revit, and that's the analytical model of a small structure in Revit. I'll show you the 3D view of that. Excuse me? This was 2015, yeah, I think. Yeah, that should be 2015. Yes. Good question. That would have been embarrassing. So we'll take a look at this physical model versus the analytical model. So you can see that as the physical models here, at the same time Revit is creating and maintaining an analytical model in the background for you. For each of those elements, the physical model has some controls over whether the analytical model is enabled or not. So if you have hangers or stair posts or something that you might not want to consider in your analytical model, you can control whether or not the analytical model that's associated with the physical model is. So that control is here. And then the other way around, the analytical model itself, for a column, for instance, we'll look at some of the properties available for that. So in the analytical model of a column, I have structural analysis parameters. What are the releases? So columns by default are fixed, of course. Beams by default, if I grab one of those, we put those as pinned, and pinned with torsion released on one side. So we can control member end releases in the analytical model in Revit. So all this is for geometry stuff. And each analytical model is intrinsically tied to or understands that it lives and dies with a physical model. So there's no longer a chance that we can have an analytical model in the analytical element in the model that doesn't match up with a physical element that's available in the model. So they're tied to, they live and die together. And one of the ways you can see that is in this drop down up here. You can see that as I've selected this analytical beam, in the drop down I also have the associated structural framing member that goes with it. So I could switch between those two things and see the properties for that associated structural model as well. So the analytical beams we'll talk about a little bit more, some of the properties down here. Analyze as, in the original implementation, some of the linking partners needed some specific parameters to work on. One of those softwares dealt with whether a thing was gravity or lateral. That was an important distinction for them. Some people may know exactly who that is. Analytical links, you can control the way that these columns and beams work together, whether they are beams coming directly to the center line of the column or at offset with a rigid link so that you can model some of that eccentricity that you might want to model in a particular case. So you can control how that works automatically. A lot of work was done. Actually, it was around 2006, 2007, between 2006 and 2007, a lot of work was done on the analytical model, and we created this feature called Auto Detect. And the goal of Auto Detect was to try and keep the analytical model connected. We all know that an unconnected analytical model is not terribly analyzable. So the analytical Auto Detect functionality does a good job of trying to keep things together. So you can see that most of these things are connected. I actually modified this so that, let me undo that modification so you can see where these are. So if I go and edit the boundary of that slab, this is one of the slightly hidden features of the Auto Detect when it comes to slabs. Each model line, or sketch line, so to speak, in that slab floor sketch has an analytical property called projection. So it's a little tricky there. We've got analytical properties embedded in a physical creation editor. But the projection I changed to edge of slab. If I set that back to Auto Detect and finish that slab, we go and look at the analytical model, you'll see that that's, I'd only changed it for one. We do that again. That's a little app called ViewSync. It's available on the Revit Exchange App Store. Anyone use the Revit Exchange App Store? Anyone been there, checked it out? Yeah, definitely go out there and check it. Thomas. I should introduce Thomas to you so that you know. Thomas Fink is up here in the front. Is Armin here? No. No? Just Tom? Different session. Thomas Fink is the owner of Sophistique, a structural engineering analysis company, a structural analysis provider in Germany. And they, of course, provide structural analysis and design for the world. And we're going to see one of their tools in a few minutes that I think is pretty compelling. So I'm just going to grab all of those analytical models or those edges and set them to Auto Detect so that you can see what this functionality looks like. So I changed them all back to Auto Detect. If I zoom back in and look at that, we'll see that now that slab edge is auto-detecting to the column instead of being where it was at the edge of itself. So all of these rules and projections can control where the analytical model winds up relative to the physical model that represents it, or that it represents. So I'll undo that a couple times just so you can see what it looked like before. So if I set it to the edge, now I've got my analytical model of my floor, that sort of rouge-colored, orange-colored thing, goes all the way out to the edge of the slab. So now I'm collecting all of the load from the entire floor on that element. The other thing about the analytical model, especially with the work that they did in 2012, I guess, we kind of, in terms of separating out or creating a greater separation between the analytical model and the physical model, we also added the ability to manipulate it in almost any way you could imagine. And what I mean by that is if you select an analytical model element, one of the toolbar options is Analytical Adjust. So if I turn on Analytical Adjust, now I see the nodes at the end of these members. And if I select one, I get arrow or grip controls that highlight as I hover over them. And I can drag those and change the analytical model. But you notice that I changed that analytical model. The physical model stays exactly where it is. So one of these problems that we've got a modeling department that's very concerned about the coordination of the model, and they've got their own rules and responsibilities. How do we get engineers working in a model unless we have this separable workflow where we can idealize the structure, analytically speaking, and let them keep the physical model? I think personally, my personal feeling is that the ideal workflow is probably more engineer and drafter or designer model working closer together, not necessarily at a separation. I know there's some people in the room that work in workflows where the engineers in the office actually just do the whole project in Revit by themselves. Analysis, design, modeling, document preparation, and they're assisted by modelers that do drawing preparation and that sort of thing, management. So the fact that we can control the analytical model in any way that we need relative to the physical model without adversely affecting the physical model is pretty important. So I can grab that back and snap it onto the end of that column again. And let's see, how many elements? We have beams, columns, braces have analytical models, floors, foundation slabs, and there's also an analytical representation of an isolated foundation, but it's one of the ones that I disagreed with. It's a point at this point. So there is analytical model information there for extraction, but it's not already set up for sort of being considered a plate element or that sort of thing. The wall adjustment tool, walls didn't get the same kind of adjustment capabilities as floors. So if I select this floor, I get these grips at every corner or vertice of the floor. So I could really, do almost anything I need to do to get this thing connected. If I need to have this break, I'll need to add an additional sketch line. So I only get as many lines in this to manipulate as I have sketch lines in my original boundary, okay? So it can't deal with, at this point, this may change in the future, but it can't deal at this point with sort of breaking along that by itself. It needs to have a sketch line in the sketched boundary of the model to mimic that analytically. And so again, I've managed that or dealt with that analytical model, moved it somewhere, and it hasn't adjusted my physical model at all. So we can create a lot of our unique sort of analytical representations that we do that don't necessarily reflect physically the physical model, but are the way that we want to analyze them. And we can create those in the software. So that's what the wall adjustment tool didn't get, this fancy sort of stretchy, grabby thing. So the wall adjustment tool is a little bit more manual. Openings can be included or excluded. So if you have obviously a large opening, you want to include that in your slab or wall. But if you have a small opening or a bunch of small penetrations, you may not want that sort of complexity in your analytical model. You got 1,000 million little elements around those tiny openings. The openings tool allows you to just ignore those small openings. They get little check boxes on there. Let me show you what that looks like. I'll just put an opening in this floor somehow. No, it's a beam. Put a little opening in there, finish that up, and then get back into this analytical adjust mode where I've got my openings tool. So if I click on the openings command or openings editor, you see there's a little checkbox. Can you see that pretty well? There's a little checkbox there. So if I uncheck the checkbox and finish that analytical edit mode, now my analytical model doesn't have that little tiny opening that I really don't want to analyze. It's obviously up to you. There's also a rigid links tool. The rigid links tool, as far as I know, Joe, can only go between nodes at the ends of members. Yes. So a great functionality for an analytical link might be to create eccentricities on members, et cetera, but for the time being, it's a tool that lets you connect up nodes that might not be connected, or you can't get to connect in a certain way, or you actually want to model them with a rigid link. So that rigid link tool is in there as well. So a lot of tools and features that look a lot like analysis software, but in Revit. And we're creating this analytical model as well. So we'll talk about some of the other analytical tools going along the Analyze tab. We have load cases. So how many load cases do we want to consider? We can create as many load cases as we want. We can manage the load natures that we assign to those load cases. As far as people, if you want to use the robot structural analysis link, the load natures are important and they're used in terms of determining what those load cases get combined as. I assume that other links do the same thing, but I'm not sure. Sure. The question is the default that self-weight is included in the load cases, and it is not the default. So even though Revit understands the elements that it has, there is not currently a tool to apply dead load per those physical elements and the things that we know about them. That said, nothing says we couldn't create a tool that does that for us, but is not automatically included. When you go to robot, if you want to use robot, it does take the first load case is the global self-weight. So you could ignore the dead load of the elements, the modeled elements in Revit, and on a link to robot. Does Sophistic do the same thing? And Sophistic does the same thing. So if you go right out to either of those two, at least analysis packages, they will assume that the self-weight of the elements is the first case. So you don't have to worry about that. Okay. Oh, it's a checkbox in each load case. All right. So in Sophistic tool, Thomas just said that it's a checkbox in each load case. So you can decide for yourself whether you want to do it or not. So we have the ability to pre-create load cases as well as combinations. So I can create my load combinations directly in Revit. Now this is a bit of it's not the thing that you want to do yet. Hopefully there'll be some tools to help facilitate this in the future. But in terms of adding a load combination, we have to click Add here and give this sort of a new name. Like, let me get myself a little more room to work with. We'll do 1.2. And somebody tell me, I've been out of engineering, direct engineering for a while. When we're combining live load with wind now, is it wind's an ultimate load now, right? 1.0? So what's the live load associated with that? 6? It used to be 3, I think, or something like that. So I'll do it anyway. It doesn't matter. So I'll do that. But now I don't have a formula yet. So this is just what I've called it. And in order to create the formula down here, we'll click the Add button a couple of times to add factors. Select those live load and the wind load and give them parameters or give them factors. So you can see that doing this type of thing for 500 load cases, not what we want to do. So I would encourage you at this point at least to work with whatever analysis package you choose to work with and let the analysis package derive those load combinations for you. Most structural analysis packages I know do that very adeptly. And so this is a manual kind of input, but you could also create custom load combinations and that sort of thing that you want to deal with. We'll look at some of the analytical model settings as well. Since we're on this tab, we have some ability to do some automated checking of the analytical model. It can tell us about things where there's not connectivity of the model. You get a large model with a lot of things going on. It's difficult to visually discern what's going on or what's happening. So you can utilize these automated checks to look for places where beams and floors overlap or instabilities are possible or any of these sort of things. You can also check for circular references or interesting structural engineering. You also have control over this auto detect. So I talked about that auto detect feature. And basically what it's doing is it's sort of each analytical model is looking around itself for anything that it might want to attach to or that might want to attach to it. And when it finds something like that, it does. And the way it determines how far it looks are these auto detect settings here. So 1 foot might be a little bit much for most people. So you might want to knock that down a little bit. But if you see something strange happening with your analytical model, it's entirely possible that you're using auto detect and it's within one of these tolerances. So you might want to think about that, consider how you want to use your tolerances. Boundary condition settings. This is purely a way to map families that represent boundary conditions to the element that is the actual boundary condition. So what's in here are literally RFA families that represent the boundary conditions. It's purely for graphics. There's nothing magical about this. And it's actually a little bit pedestrian when I think back on it, but I was kind of involved in that project too. And then the spacing that you want to see visually between those boundary conditions. So I'll hit OK on that. So the boundary conditions, it's probably worth talking about next. Obviously, this looks pretty familiar. It's a fixed boundary condition. We have a series of pre-loaded sort of boundary conditions, and that's what's being set up in that other thing, pin boundary conditions and rollers. And then you have the ability to create a user boundary condition. And the user boundary condition can be oriented to the project or the local host coordinate system so that you can create and model typical boundary conditions that you might have to create. And you can control the 3 translations and the 3 rotations at each node. We also have boundary conditions that are, I keep saying we, it's hard. After you work for a company for 8 years, it's tough to get out of that mode. When you start the boundary conditions tool, you have the ability to place point boundary conditions, line boundary conditions on linear elements or edges, and area boundary conditions as well. So if we look at one of these user-defined, you have 3 options under each translation and rotation. So you can do a fixed, released, or you can also have a spring constant applied, regardless of the fact that the geotechnical engineers don't like it when we use spring constants for foundations. You could use them here and model them as well. And one of, well, let me just change the one that I've got instead of making a new one. This is my little contribution to the visual interface of, do it in the Z, the visual interface of Revit. This was my graphic that I made at like 1 o'clock in the morning one night. They were like, what are we going to use for graphics? And I'm like, I don't know. I'm going to make something up. So, enjoy those. Those are mine. If they look strange, they probably are. But anyway, I'm going to change that back to something more easy to facilitate analysis of this particular structure. And then we want to talk a little bit about loads. So we've talked about boundary conditions and the loading capabilities of Revit. So you can place hosted versions of a point load, nodal loads only, ends of members, hosted line load, as well as a hosted area load. So those are sort of typical standards. With the hosted line load, you can have a non-uniform load. So you can have a trapezoidal varying load, but it can only be from one end to the other. So it's not something where you create a sort of sawtooth pattern along the element or anything like that at this point. What you would want to do if you wanted to do that is use the standard line load and create several of them along your member to model that loading pattern. Again, something that I'm interested in and sort of driving these technologies is we could create loading tools. There's just not a lot of demand right now. There's not a lot of people using Revit for engineering. But we could enhance these loading tools. We could automate these loading tools. The boundary condition tool, as a for instance, you can't select multiple nodes at the bottom and apply those boundary conditions all to the bottom. You have to literally click each and every single one. So there's some automation possibilities there and things that can be facilitated by that. If you use the non-hosted area load, you also have the ability to add reference points to the sketch that you create. So let's say I wanted to create a load on here. I'm going to set my work plane to level 2 so that it winds up in the right place. And then I'm going to create a sketch of a little, let's say that there's a snowdrift on this side or something like that. Using the reference point tool, I can click corners of this sketch. So I'll make that 1. You see the little 1 shows up there in gray. 2, and I'll make that one 3. And now in the properties of that load, not only can I control the case that it's going to be added to, what its orientation is, but now I have 1, 2, and 3 that define the coordinates of those, or that define the pressures at each of those points. So I can do -1 and -1 and whatever. We'll just leave that at 0. And then when I finish that load, now I've got a nice, very dramatic snow load on my building. So that's not possible with the hosted area load, but it is possible with the plane area load tool. And just in order to make this work, I'm going to get rid of that little puppy. Okay, so that's a little bit about loading. There's no sort of special loading available. It's just static load cases defined. There's also not a real easy way to turn on and off load cases. If you go to visibility graphics, the analytical model now, since 2012, has its own tab at the top of this visibility graphics. So you can control a lot of these things. What you see in that view, we just don't currently have per load case because it doesn't know what the load cases are beforehand, but it does know by nature. So that you could create views with these things. We could create filters to turn these things on and off, but it's not yet facile. It's not easy. It's not sort of like you would expect perhaps in a structural analysis software. Just kind of a gotcha for the time being. So that's a quick tour of the analytical model. Does anyone have any questions about the analytical model at this point? No. Pretty straightforward stuff. We've done this for years and years and years. That functionality is available in Revit. Yes? Is it possible in Revit to assign a boundary condition on the footing object? Yes. Yeah. So some analysis packages, when they do the translation from Revit into the analysis package, interpret isolated footings or foundations as some type of boundary condition. The robot structural analysis link does this, and I actually don't like it. I mean, it's great that you figured out for me what I wanted to do with my foundation in terms of boundary condition, but I'd rather model it myself. So it is possible to put them on there. I've put all of these yellow, you can barely see that on this. Let me zoom in a little bit. All of these yellow are boundary conditions. If there's a footing that gets inserted, the footing analytical model in Revit is literally a point. It's just an XYZ location. It has some data associated with it so that analysis packages could read that out, but it's just a point at this point. You could assign that boundary condition to the foundation if you wanted to, but they kind of wind up coincident at the same point, and most analysis packages would just take it as the bottom of the column anyway. In order to model, for instance, a pedestal on top of a isolated footing, if you really wanted to model that in Revit and send it out to analysis, you basically have to model a foundation slab, which is a surface sort of element, and that column on top of it to get the kind of functionality that you might expect for a foundation like that. And you could apply an area boundary condition to that footing. But if you wanted to, say, do a more rigorous analysis where you've got springs underneath your footing, you can only apply one spring constant to the entire bottom surface of that footing if you model it that way. So you'd have to, if you really wanted to model it with springs that vary along the surface, you'd have to go into a more advanced analysis package to do that. Any other questions at this point? Yeah. Mm-hmm. Sometimes, yeah. So the question is, it's great that we can manipulate the analytical model relative to the physical model. What can we do with the physical model, or what happens when you manipulate the physical model? What happens to the analytical model? Sometimes it snaps back, and sometimes it doesn't. That's kind of what happens. So we could actually, we'll try one and see what happens. It's a little unpredictable sometimes. I mean, it's consistent in its unpredictability, but I can't tell you exactly what it's going to do at any one moment. So if I move that, so it sort of left the column, the beam attached to the column, and then the other end went with it. So there are some unpredictable, or I don't know what to call it unpredictable. There is a code and logic that controls this, but it may not be immediately intuitive what you want to do with it. But you could always fix that pretty quickly. You'd also see that it's unconnected as well, so you'd have some unconnected warnings if you turn those on. But you can quickly adjust that, grab it, and drop it back on top of where it was before. So undo that.
I think this can never be automated.
It's
need an engineer to control
Yeah,
that.
it's a good point that Thomas brings up. As software developers and in that sort of how do you deal with stuff, you have to try to think of all of the incredibly numerous permutations of things. And it's a discussion that comes up all the time. what would you want it to do? Those are the developers come to us and say, well, what would you want it to do? And we're like, well, in this way, we'd kind of want it to do that, and that way, we'd kind of want it to do that. And they're like, well, we could write code for the next 40 years and maybe come up with that behavior. So it's a good point that a lot of these things are difficult to predict what the user would actually want anyway. And Revit, one of the tenets of Revit was to try to not over-predict for you. Auto-detect feature was a real sort of departure from that in terms of trying to predict what you want. So I want to keep moving. If there's no other major questions, if you want to get more in the nitty-gritty of this later, feel free to come up and talk to me afterwards. We can talk about this all day long. I could for sure. But I don't want to drone on too long about the analytical model. But I do want to show what we can do with this thing in terms of going out to analysis. I'm going to take and reset my floor analytical model if I can. This is the beauty of doing, where is that? There we go. Reset manual offsets over there. That was a helpful little tool. Doing a live demo is always kind of interesting, but where's the fun in doing something with videos? It's just unpredictable this way and more interesting. So we'll take that. The structural analysis panel, some of you may or may not have this in your Revit. This is available with the Structural Analysis Toolkit 2015. There's also one for 2014, if you're still in 14. That's available in the Autodesk Exchange Revit App Store, and it's a free download, okay? And that brings in these tools, Robot Structural Analysis Link, Analyze in the Cloud. Actually, Robot Structural Analysis Link may come in with the robot installation, but I can't remember for sure. And it brings in these new tools, Analyze in Cloud, Results Manager, and the currently grayed out because we don't have any analysis results, Results Explorer. So I'm going to start with Analyze in the Cloud. I'm going to also go to Robot because I want to show bringing some design packages back into Revit. So I'm going to go Analyze in Cloud. I think that I have internet connectivity, but we'll see. Can everyone still hear me over in that corner of the room? Everyone good? Okay. So when I click Analyze in the Cloud, the first thing it's going to do is start to check what's checking entitlements. Do I have the access to use Autodesk 360 structural analysis? It's done on a credit system. Okay, so you have to have cloud credits, and then you have an account balance of cloud credits. And each analysis, unless it fails, deducts from your cloud credit account. Say that 5 times fast. So you can see down here, I have 64 cloud credits left. In order to run this analysis, it requires 2 cloud credits. Yes? That's a very good question. Everything's done with this single sign-on. So the question was, how do you manage who can activate cloud credits, and how do you manage the cloud credits sort of on a larger level than just an individual user? Currently, it's all per individual user. So I think that this is something that Autodesk, I assume, will be working on over time, is to be able to aggregate that management and control at a potentially BIM manager or BIM director level kind of thing. It's a new thing, so they're kind of working out the bugs in the business model, how they want to monetize this and control it and give access to it. They're doing the same thing with rendering. There's rendering in the cloud now, and they're looking at all kinds of other things that they can put in the cloud. And I'm sure that you've heard cloud more times than you probably want to in one weekend or 1 week while you're here. But it is sort of it's a direction that Autodesk is definitely going with things. And you'll see that currently what we can do in the cloud with Autodesk 360 structural analysis is static analysis. If we want to do anything more advanced, nonlinear, P-delta, et cetera, we have to go to an advanced analysis package like Robot, like Sophistique, like any of the other packages that are available out there that link with Revit in some way. So you can give it an analysis name, select the report template. There's only 2 available. There's no control over what's in the report template. It's pre-canned at this point. You can give that name or report a name. The analysis profile allows you to choose between a lightly meshed, sort of not very detailed, all the way up to a fine model, depending on what you need for your analysis. So in theory, you've got the cloud, and it's more powerful and lots of computers, and the reality is that it's about as fast as it would be on the desktop, maybe a little bit faster, but they're working on that. That's something that they realized. So their first task was to get it up in the cloud. Their next task is to optimize it and really utilize that power of the cloud to drive analysis for large models. Can you imagine the last model that you ran that was complex on your desktop and you had to sort of go out for lunch and come back and hope that it ran? Imagine if you could just pop that up to the cloud and get back to work. You don't have to sit around and wait for it. Or it happens so fast that you don't have to go get lunch. Well, it's nice to have lunch. So you have some self-weight options. You can either have the self-weight. This goes back to your question before, your question about self-weight. You can have it add to the existing, or we're going to ignore it because we did it before. Question? Yes. Yeah. They're exposed through something called the results builder, which is part of the SDK. So if there's results packages that get stored back in Revit, you can then read those results packages, read the contents of those result packages to do any analysis or design that you want. You could drive them into your Excel chart, in Excel spreadsheets, or iteratively drive them in, or whatever you want to do. So those will be available. So I'm going to ignore that, and we'll call this Model 3 just in case. And Analysis 3. And I'll start that analysis. So what it does then is perhaps, no, good stuff. All right. So down in your system tray now, the way that you're going to find out what's going on with your cloud analysis is down in the system tray icon, the structural analysis for Revit. If you click on it once, it opens your message center so you can see what's going on. Simple slab and boundary conditions, Model 1 completed. I ran that one last night, sort of practicing this stuff to make sure everything was working the way I hoped it would. And now you can see that as that model has been accepted by the cloud for processing, you can see the status of that. If I open Dashboard, that takes me to a web portal. Dun, dun, dun. Web portal. We're going to take me to a web portal where I can look at all of the analyses that I've run before, interact with them in some ways, and digest them as well. So here's analysis 1. This is my analysis that's in progress. It's running right now. I know what the status is. And then I've got a failed one down here as well. So these are previously run analyses, so I'll take a look at this one just for instance. Sort of thought that the hard wire connection would be faster. So I get a list of all of the analyses that have been run on this model. I could start a new analysis or launch a new analysis directly from here. I can delete that model. I also have the ability to look at a 3D view of that. So what has it done? So we're in the cloud now. We've gone from Revit, and somehow it's magically meshed it, right? We didn't go through any meshing process. So what does it look like when it gets analyzed in the cloud? So there's a little 3D sort of, I don't even know what to call that, 3D thing with a cube. If you click on that, we'll get a in the cloud model viewer that lets us take a look at exactly what model was analyzed or is being analyzed by the cloud. So we can spin that around. I saw somewhere that errors would be available for digesting here if there's any instabilities found in the model or anything like that. You could look at those here before you went back to your desktop with it. And the view also has some settings that are available. So you could turn on loads and look at your different load cases and combinations. Turn on or off, the mesh or whatever you want to do. So you can get a little bit of a chance to digest this model even while it's still in the cloud. You can understand what it's done in terms of meshing. You can get some confidence on what it's done there before it's even finished analyzing. So you can still taking a little bit of time there. We'll go back to, sure.
Any control over the meshing whatsoever? Just magically done and you have to accept it for what it is?
Yeah. The question is there any control over the meshing or is it just magically done? And the answer is it's just magically done with the exception of you can set the draft, normal, or fine resolution. So a fine would get you a finer mesh. The draft would get you a less fine or a drafty kind of mesh. There's no control over actual meshing parameters. You can't add emitters. You can't deal with which meshing algorithm is used. It's just whatever they chose. I'm not sure what it is. If you don't like the mesh that it chose, you need to spend. Yeah, I think you need to spend another 2 credits. Why do you think they use it Vegas? They could have had it anywhere in the world.
I think it pretty much just uses one engine for the meshing,
Yeah.
as opposed to what you can have in terms of flexibility inside a robot.
Mm-hmm.
But you did have that advanced tab
Mm-hmm.
right before you click the
Yes.
analysis. I'm just curious what's inside.
I'll show you.
Okay.
So the question was, there was an advanced tab right next to the simple static tab, and I just want to show you what that looks like. We're still waiting for that analysis to run. I've got some other things we can look at, but we'll go pop back into Revit. See, the other nice thing about this is I can continue working in Revit. I'm free to continue modeling. I can start setting up views while I'm waiting for this analysis to run, if it happens to take a long time. I'll go back and go to Analyze in the Cloud again. Dun, dun, dun. And it's going to check and make sure I'm legitimate Autodesk 360 cloud user. You see the other things that it's doing, extracting the model. So it's taking that data and sending it up to the cloud, checking to make sure that the cloud can run stuff. You can see that my model's just finished running. Verification of the model, and that sort of thing. So if you get a situation where it won't mesh, your question, where it won't mesh, you won't probably be charged for 2 credits. But if you get a mesh that you just don't like, probably have to pay the credits. So the advanced analysis, you're welcome to purchase robot structural analysis. It would be interesting if it did. It really would. I think that that's probably that might be a more interesting workflow than sort of having an advertisement over there. But that is what it is. So it's just the advanced analysis is provided by robot structural analysis or by whatever analysis package you have that also links with Revit structure. So it's a static analysis at this point. I'll tell you that if you went and met with the product manager for storm analysis, that's the sort of the background code name for this, and said, we love the thought of analysis in the cloud, let's get more advanced analyses in there, they would be excited to hear that. So,
do you know whether the credits are going to be the same amount of credit for any size model?
It's a very good question. The question is, do I know if the amount of credits will be the same for any size model or not? And I don't.
I've worked with Sim 360, which is pretty much the robot engine on the cloud.
Mm-hmm.
So from my experience, I think you're going to spend a bit more, like 5 credits, for a much more advanced analysis.
Wow.
Compared to this one.
Okay. All right, so the answer to that from another person in the audience, this is being recorded, so that's why I'm repeating everything, is that their experience is that more advanced analyses may require more cloud credits to run. So anyway, it is a foray into the new world of cloud-based everything. So I'm going to look at that completed analysis, taking back out to the web portal, which I probably should have done in the other. Anyway, so I go back to that web portal and I can look at an initial report of the analysis of that model. So here's my model names, what I chose for options, and then it gives me a view of the structure, gives me the view of the meshing, shows me the loads and the combinations that it evaluated, supported elements, gives me a chance to look at the reactions of those in the cloud before I even get into looking at it anywhere else. And sort of gives you a bunch of information you can dig into a little bit. Forces in the members, you can get some quick feedback about your structure, how it's working, reactions on the foundations. Geotechnical engineers always saying, can you give me all the foundation loads? You can do this pretty quick with this. Set up a static analysis, throw it up in the cloud, let it run, send the report over to the geotech, and they can get a visual graphic of all of these things, including moments in the slab. What are the moments currently looking like? You can investigate those. This is a canned report. They decide what to give you at this point. But the next thing that we're going to look at, close that little mini dashboard here and close that dashboard. The next thing we want to look at is, hang on a second, I'm supposed to do this. Results management and exploration in Revit. This is the next flavor of our demo. So now that I've done that static analysis, the results manager allows me to access all those results. So I've got model 1 that I ran before, model 3 is my new, you can see that that's up to date, and both of those results are remote. So if I want to get those back into my Revit model, I can download that. Hopefully this will work. It was causing some problems yesterday. I'm not sure what I was doing wrong. Wow. So it was bringing those results down and creating that results package inside of Revit that then will be available to the API. So it's entirely possible that someone could write a Dynamo node that would give you access to those, and you could use that in visual programming, for instance. Might be a fun way to do that. So in project and remote, and you can explore those directly from here by using the Explore button, but hitting Explore leaves this dialog up anyway, so I'm going to close that and go to the ribbon tab for Results Exploration over here, Results Explorer. So what that does is it reads through all the results packages that are available. So you can see I've got model 1 and 3, so there's my model 3, analysis 3, and all of my load cases and combinations that were evaluated. So I can look at 1.6 dead and live. All of the results that are available for viewing are over here. So I've got results for members. We can take a quick look at our moments, apply that, and you'll see that now we're starting to look at something that looks a whole lot more like structural analysis inside of Revit. You can control those things. We can turn those off. We'll look at results for surfaces. We can look at the moment in the, I guess this is Y probably. The other way. No, it's X. So I can look at results on those surfaces, get a sense of the moments. And at this point, there are no tags on there, but I could also add tags so I can visually get a readout of those things. The other thing that we can look at are reactions. So I could look at the reactions in the X, Y, and Z. I can apply those at the boundary conditions. Start to look at the reactions. They're overlapping, and there's no way to control that, unfortunately. But you could just look at them independently. So you can start to see how you might set up different views of your model to document your calculations, because your results are now inside of Revit. You could use Revit to drive your documentation in terms of preparing those documents, et cetera, and reporting your analysis results. The last thing that we'll look at down here, you can turn on and off multiple of these things at once. There's nothing to stop you from doing that. You hit apply with that, and we can also look at the deformed shape of the structure based on which load case or combination we're looking at. So does that start to make Revit look a whole lot more like a structural analysis tool? It really does. Like you're getting the sense that you're not actually working in a physical 3D building information model, but working more. I mean, we've been working in 3D for much longer than the modeling staff has. We model almost all of our buildings in 3D. I mean, unless we go far enough back where we're on hand calcs and that sort of thing, we may or may not have done that. But being able to bring these results back into Revit is a really powerful thing in terms of visualizing those results and saying, do I have this thing designed appropriately? Now you're looking at the actual analytical model. You know there's a physical model associated with it, and you're seeing the results of that as well. If you expand the Results Explorer, you get some more control over the display of those results, those analysis results. So you can change the units that are used to display them. You can change the scaling, so you could scale that up or down depending on how visible it was or how large or small it was. And you also get an indication of the max and min value, so you get a quick sort of global overall max and min for this quantity as well. So that's one way to change it. The other thing that's important to note is that this is an analysis visualization style, and we can control those styles. They've created a bunch and already pre-selected them. But I will, if you look over in your view, so this is the 3D analytical model view, every view that has analysis results in it will have this button. And if you open that button, you can see what analysis results are currently visible. There could be multiple results listed in that view. Again, this is a mimic of that information that we saw in the Results Explorer. We can change the units used to display it. We can change the scale. This is a little bit less user-friendly way to change the scale. And you can see the max and min values as well. If I go to this analysis display style and click the ellipsis button in there, you can see all of the analysis display styles that there are, and you can change all the settings for them as well. How are we doing on time? Are we losing it? Wow. I can talk. We're going to move on really quickly to get into some other stuff. Anyway, I want you to realize that there are analysis display settings in there that are available. So quickly, I'm just going to open another model. I'm going to skip the analysis portion of it and show you something that I find really impressive. Let's see if I can find it first. It's getting to be about that time in case anyone's needing to get over to a different presentation. I'll just keep going until they kick me out. So Sophistique has put together a tool set that I find incredibly compelling. And what they've done in terms of, this is really the bringing structural engineering inside of Revit. So let me go to where it is, here, I guess. So you can see that this beam, I'm going to get rid of this reinforcing in the beam, like so. Delete it. And then I'm going to select those two elements. And I'm going to start, here's this new tool from Sophistique. Sophistique Reinforcement. They also have a bunch of tools for reinforcement detailing and documentation. So check them out on the Revit Exchange App Store and also at sophistique.com. It's just .com, right, Thomas? Yeah. And you can see what these tools do. You can access videos about them that will probably be more exciting and interesting than this particular presentation. But check them out on the web. The Create tool uses analysis results to drive reinforcement in those members. So what I've got is a tool that looks a little bit like the Revit extensions, for instance. And we've got some control over, this is the database from Sophistique that contains the required reinforcing results. The Sophistique tool at this point will take required reinforcing results for slab and wall elements from robot structural analysis, but not for beams and columns at this point, but they're working on it. This is currently, they're calling it a labs tool, but it's actually quite well done. So labs means kind of beta. You can access this on the Revit Exchange App Store, play around with it, give them some feedback. They'll want to hear from you. It's a free trial at this point, so it's sort of a beta labs version. In the settings, we have a bunch of control over how this thing is done. So there's a settings file that lets you control some things like diameters for longitudinal bars. What diameters do you want to allow this tool to choose in terms of taking the required analysis results and creating reinforcement in the project itself. So there's a whole bunch of different settings. You can control how it does rounding and bends and construction bars, and all of that's controlled in this text file here. And then I'm just going to go ahead and say create reinforcement diagrams as well. We have some control over what's happening here too, but just to get moving along a little bit, if I do that, thank you, it will create diagrams on those members. The red is this is all done with the analysis visualization framework. The red is the required amount of reinforcing in the member. The blue is the provided amount of reinforcing in the member. So now we're doing, so check this out. And we're not done yet. So let's say I want to, here's this thing. This was something else I was involved with at Revit, and I really don't like the way it's done. This structural rebar, does everyone know about this structural rebar view visibility states? Everyone know about that? You can view rebar as solids in the model if you want, and view it unobscured. I thought it should just be a view state, but here's that set of additional rebars, sort of for the increased moment section. if you didn't like how close we got to that required amount of reinforcing, you could, let me try and get those again, grab the shape handle, and watch what happens when I drag this shape handle. See that the amount of provided reinforcing is updating live. So this is taking advantage of two things that are important in the Revit API, the analysis visualization framework, as well as the dynamic update. So that as you change things and move them around, and if you go ahead and take that rebar and delete it, for instance, now you see that you don't have enough provided reinforcing for what you have in required reinforcing. I am out of time. I cannot believe it. I thought that I was going to be just standing around for half an hour just taking questions. I'll be happy to take any questions that you have right now at the end of this. You're more than welcome to contact me via email. Get in touch with Thomas if you have any questions about this Sophistique tool. This doesn't just work for beams and columns. It also works for slabs and walls, so that you get cross representations of required reinforcing and amounts so that you can, and it takes into account not just what it created, but if you put rebar into the model itself, it accounts for that as well, so that you can pop in a standard set of rebar that you want and compare what you've provided against what's required. So I hope that this gives you some sort of indication that this is really bringing engineering and engineering workflows directly into Revit. I'm in Revit doing engineering. So I hope that that's been interesting and informative. I've got a couple of things just in the last second here I want to cover. So I want to encourage you to learn more about programming, Revit APIs and Dynamo. Robot API, if you want to use Robot, has access via their API to all of the analysis results. So you could write your own stuff to dig in there, write your own code checks, etc. Learn more about the code checking framework. Because I didn't get a chance to get to it, I will create a video. And I think I have all of your emails, so I'll just shoot you guys an email with that either link, or I'll try to put it on this. Autodesk has this new thing that's like you can record a screencast or something. I'll try to make one of those for you and make that accessible afterwards. Also, the handout has a full detailing of this code checking framework, what it does, how it's used, and the possibilities for future. You could write your own code checks on Revit using the code checking framework. It requires a little bit of programming, but it's not inaccessible. And I would really strongly encourage you to participate. Reach out to the developers. Thomas is right here from Sophistique. He can talk to you about FEA Sophistique, reinforcement detailing. He can talk to you more about this particular tool that I've just showed you. I'd strongly encourage you to help shape the tools that we're going to use or will be affected by in the future as this new development comes along. Thank you so much for coming. I'll be happy to take any questions you have afterwards. I have cards if you want them. And please do fill out the surveys. The AU organizers use those survey feedback results to decide how to best program for next year and what you were interested in. So please do that, and you'll find that on your mobile app as well. Thank you so much. And